Lesson 6-1, Operations on Functions. We're going to look at how we can add, subtract, multiply, and divide functions, and then be able to graph them in the end. For the first part, adding and subtracting fractions. Here we're going to take our fractions, our functions, and we're just adding like terms. So the first one, I have negative x squared plus 3x plus 1, and we are adding 2x squared minus 5. I'm going to put a plus 0x here and minus 5. Add straight down, and I get x squared plus 3x minus 4. Letter B, we are subtracting the functions. So if I have negative x squared plus 3x plus 1, I'm going to be subtracting 2x squared minus 5. And when we subtract with functions, you have to remember we're distributing a negative 1 here. So it would be negative x squared minus 2x squared. Then we have plus 3x. We don't have any other x's in the second one. And then it's going to be a plus 1 minus a negative 5. So when we combine like terms here, we're going to have a negative 3x squared plus 3x plus 6. Next, add these together. So we have 6x plus 5, and we're going to add a negative 4x cubed minus 3x squared. I don't have any like terms, so if I put this in standard form, I have negative 4x cubed minus 3x squared plus 6x plus 5. And then we're subtracting them. If I'm subtracting g of x from f of x, I need to distribute a negative 1 here. Just means change all the signs. So this would be 6x plus 5 plus 4x cubed plus 3x squared. That will give us an answer of 4x cubed plus 3x squared plus 6x plus 5. That would be in standard form. Next is multiplying and dividing. Multiplying, you're just distributing when you're multiplying the functions. So if I have 4x squared minus 2x plus 3, and I'm multiplying that by negative x plus 5. So if I distribute, this gives us a negative 4x cubed plus 20x squared. Then distribute the negative 2, and that'll give us 2x squared and a minus 10x. And then the last one, distribute a 3, and that gives us a negative 3x and a positive 15. Add straight down, and we get negative 4x cubed plus 22x squared minus 13x plus 15. And letter B, we take f of x, which is 4x squared minus 2x plus 3. And we're going to divide that by g of x, which is negative x plus 5. Now with division, we have to see if we can simplify the numerator and denominator. We do that by factoring. So factoring the numerator and then factoring the denominator. The numerator I cannot factor. So my answer would have to stay put. And then I have to put down what x cannot equal in the denominator. And x cannot equal 5. Because if x was 5, that would make that denominator equal to 0, and you cannot divide by 0. So this would be my simplified answer. A couple other ones with multiplication. Here I have x squared minus 36, and I need to multiply that by x plus 6. So it distributes, and we get x cubed plus 6x squared, and then minus 36x, and minus 216. I cannot combine any like terms, so this would be my solution. And letter B, we're going to divide those. So we have x squared minus 36. Divide that by x plus 6. I can factor the numerator. That's a difference of 2 squares. So x minus 6 times x plus 6. The denominator, I have x plus 6. And the numerator and denominator have common factors of x plus 6. They divide out. So my answer would be x minus 6. And then in the denominator, I have to go back to my original problem. If x was a negative 6, that would make it equal to 0. So I cannot have negative 6 in the denominator. Moving on to a couple more, multiplication and division. Here I have negative x squared plus 1 times x plus 1 distributes. That gives me a negative x cubed minus x squared, and then plus x and plus 1. Nothing to combine, so this would be my solution. And down here, we have negative x squared plus 1 divided by x plus 1. If I do a little bit of rearranging, so just flip the terms around, I would have 1 minus x squared and 1 plus x. Now I can simplify this because the numerator is a difference of 2 squares, which would be 1 minus x and 1 plus x. And the denominator, I have 1 plus x. The 1 plus x divides out, and I'm left with 1 minus x. And then I think x cannot equal, now look in the denominator, x cannot equal a negative 1. And if x was a negative 1, it would make it 0, and I can't divide by 0. Or you could just flip these around and have negative x plus 1, and you would still have x cannot equal a negative 1. Either way, that would be your solution. Example 3, we're going to be graphing. It says the population in millions of India T years after 1955 can be modeled by a linear function f of t equaling 15.7t plus 344.2, and the population of the United States in millions T years after 1955 can be modeled by g of x equaling 2.6t plus 165.8. Define and graph the function that represents how much greater India's population is than that of the US by year. So we're going to have a new function, and we're going to name this one, we'll just make this one h of t. H of t, I'm going to take my f of t, which is 15.7t plus 344.2, and we need to subtract, because we want to find out how much greater, means we're comparing 2.6t plus 165.8. So h of t will equal 15.7 minus 2.6 gives us 13.1 t, and then 344.2 minus 165.8 gives us a positive 178.4. So this is the function that we are now going to graph. So this is h of t equaling 13.1t plus 178.4. Now my coordinate plane, we're only going to use positive values because I can only have positive number of years and positive population. So I'm going to count my numbers. So the x's, I'm going to count by 5s. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45. And then the y's, we're going to count by, we can count by 100s. So this would be 100, 2, 300, 400, 500, 600, 700, 800, 900, and 1,000. now we can plot our points on here and do this. Let's use our calculator here. So we'll go to our y equals, type in our equation here. So we got 13.1, and then we'll use x for t, plus 178.4. We do a table of values, so second graph, we're only going to go with the positives. We're going to change our scale to just count by 5. So we'll start at 0, and we'll count by 5s. Then so 0 and then 178. So 0, 178 would be roughly here. We have 5 and 243. Be roughly here. 10 and 309. Here. 15 and 374. So yeah, 10 was over 3. Let's make this roughly here. 15, 374. So up here. Then 20 would have been 440. So here. 25, let's do 505. And let's do 30 would be 571. So here, if we went down further, 35 would give us 636. Roughly here, 40 is 702. 45 would give us 767. So that's plenty of points to put down, and then we can just draw our line. So our graph will look something similar to that. Another one, a tech company produces phones earning a revenue R of X equaling 200X, where X is the number of phones produced and sold. The cost is C of X equaling 60X plus 5 million. Define the graph and graph the function that represents the profits P of X the company earns when X phones are sold. Now revenue is revenue is the money you brought in, and the cost is how much it cost to make it. Now to find the profit that you earn, you would have to take the cost minus, or the revenue minus the cost. So I'm going to take 200x, and I'm going to subtract 60x, and then I have to subtract the 5 million. And that's going to give us P of X equaling 140x minus 5 million. Now, since our y-intercept is a large number, we're going to make that a lot smaller. So when we come to our coordinate plane, we're going to adjust a little bit our axes. So here, I'm just going to write my function again. So P of X equaling 140t, or 140x minus 5 million. Now my x coordinate, we're going to count those. Those are going to be the phones sold. Those are going to be in hundreds of thousands. So that's going to be in 100,000s. If I count this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this 1 would represent 100,000. So if you think 100,000, and I'm only having it as a 1, so if I move the decimal place 5 places to the left, that equals 1. So this 1 equals 100,000. If I go back to my equation here, 1, 2, 3, 4, 5, I'm now going to have P of X equaling 140X minus 50. That 50 is going to represent 1 of 5 million. So here, if we're going to count these by hundreds of thousands, this one we're going to count by, this would be 100. So if I count these by 100, that would represent 10 million. Because if I had 50, that would represent 5 million. This is 100 million. And count by 100s here. That's 20 million, 30 million, 40 million, 50 million, 60 million, 70 million, 80 million, 90 million, and this one would be 1 billion, or 100 million. Okay, so now on our calculator, we could actually put that in. So y equals, let's clear this. We can put 140x, and then we do minus 50. This will make it a lot easier when we graph it. So now let's go to our table. So second graph. And let's go up. Gotta change our settings here. Start at 0, count by ones. Then second table. So you can see we would have 0 and negative 50. So down here is 100. Negative 50 would be here. We got 1 and 90, which would be roughly here. 2 and 230 would be roughly here. 3 and 370 be roughly there. 4 and 510, a little bit over the 500 mark. 5 and 650 be halfway between 600 and 700. 6 would be 790, so a little bit below the 800. We go down, you got 7 and 930. 7 and 930 would be roughly here. If we did 8, that's over 1,000, so that would be up here. Now we can draw our line, and our graph will look something similar to that. That would show us a profit margin, or the profit they would earn based on the number of phones that they sold. Next, an engaged couple wants to know what their combined income would be once they are married and begin to file taxes together. Suppose Casey's income can be represented by C of T equaling 32,000 T, where T is the number of years after the marriage, and Sam's by S of T equaling 30,000 T. Graph the function that represents Casey's and Sam's combined earnings after T years. So if you're combining them, you're taking C and you're adding S of T together, and that will give us 32,000 T plus 30,000 T, which will give us a total of 62,000 T. So here, we'll just use R of T. This is going to equal 62,000 T. And we can label our axes. Bottom, let's count by ones. This would be 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. Here we'll just count by 30s. So this would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. Now these numbers here on the side, so like the y-axis, these would be in thousands. this would represent 30,000, 60,000, and so forth. So now if we were to graph these, let's put this in our calculator here. Come up with our table of values. So we had 62,000 x. If I did second graph, we can see a table of values here. So we got 0, 0. We have 1 and 62,000, so roughly here. 2 and 124, so a little bit after the 120. 3 and 186, so roughly there. 4 and 248, so roughly here. And then 5 and 310, be a little bit after the 300,000. Then we can draw our line, and our line will look like that to show what their combined income would be after they are married. Next part of our lesson is composing functions. You'll know that these are composing functions, so you'll see this symbol here. It looks like just an open circle. That's not multiplication, that just means I'm using the inside function to put into the outer function. So we would read this as f of g of x. You could also see it written as this way, f of g of x, which just means you put x into g, and whatever you get out of g, you put that in for f. That's all that is saying. So the inside function goes into the outer function. So given f and g, find f of g of x and g of f of x, and then state the domain and range for each. You can see our functions here. Here we have f of x, and here we have g of x. We're going to substitute these numbers in. So we're going to put the x coordinate into g of x, and it's going to give us a y coordinate. And whatever the y coordinate is, we are going to substitute that in over here. And you'll notice that a lot of times our g of x is going to match up with the x of our f of x. So to do this, let's do f of g of x first. So to find f of g, evaluate g of x first, and then use the range to evaluate f of x. So the blue here is going to be our g of x. We're going to put x in here. So if I put a 4 in for x, g of 4 will give us 1. G of 5 will give us 0. G of 13 will give us 9. And g of 12 will give us 10. Now over here, g of x is going to go here. And then whatever our answer was is going to go into this parentheses. So I'm going to put a 4 here. I'm going to put a 5 here, a 13, and a 12. So that's just saying, I'm just rewriting this, putting this in here. That means I get a 1 here, I get a 0 here, I get a 9 here, and I get a 10 here. Now the range for your y value of your g of x is now going to be matched up with your x of your f of x. So if I have f of 1 shows us here is equal to 12. F of 0 is here, that gives us a 13. F of 9 is going to give us a 7. And f of 10 is going to give us 11. So if we were to write ordered pairs, we would go with 4, 12, 5, 13, 13, 7, and 12, 11. Because here's our x coordinates we're putting in, and then our y coordinate is over here. And just remember, when we have ordered pairs, our domain is first and our range is second. So now we could easily get to this one and do the domain of this one. So the domain of f of g, the domain was 4, 5, 12, and 13. And then our range is 12, 13, 7, and 11. So we put those in order. We would have 7, 11, 12, and 13. Now we need to find g of f of x. So to do that, we're going to use this table here. We're going to put a 1 in for x and we get a 12. Put a 10 in for x, you get 11. Put a 0 in for x, you get a 13. Put a 9 in for x, you get 7. Now this is going to go here, and this is going to go here. Or not there, this one's going to go here. So if I put a 1, 10, 0, 9, and then I put a 12, 11, 13, and 7. Now these are the x coordinates that I'm going to use here. So I come over to my g of x, and I find, if I put a 12 here, a 12 right here gives us a 10. I now find 11 in my x. I don't find an 11 in my x over here. There is no y value. So that would be considered undefined when x is 11. Find 13, which is here. That gives us a 9. If I have g of 7, there is no 7 over here. That would also be undefined. So if I come up with my ordered pairs here, I would have a point here, so that's 1, 10, and I would have a point here, which is 0, 9. Again, the domain range. So now we come up with the domain here. The domain for g of x is 0 and 1, and the range would be 9 and 10. Try another example. Find f and g. Given f and g, find f of g of x and g of f of x. State the domain and range for each of these. We'll do the same thing. So for here, put our x's in. So 12, -3, 5, and 6. Then match up with their y's, which would be 2, 12, 10, and 4. Now this is going to come over here, and this is going to come into here. So here I write 12, -3, +5, and 6. And over here I have 2, 12, 10. Actually, I have them switched around. No, that's correct. 10, and then we have 4. Now from here, I have to match them up. So f of 2. So f of 2, I don't see f of 2, so I don't have a solution there. F of 12, I do find f of 12 here. That's a 6. F of 10, I do not find f of 10. F of 4 here I do, which is -4. So my ordered pairs would be -3 and +6, and I would have 6 and -4. So if I come to here, we can now write our domain and range. So again, going back, our domain is -3, 6. So -3 and then +6. Our range would be 6 and -4. Let me put that in order. So -4 and a +6. Now let's do g of x. For g of x, we have to start with f of x. So I'm going to put a 3, 4, 5, and 12. Match those up with -3, -4, 10, and 6. So these will go here, and these will go in here. We have 3, 4, 5, and 12. And over here we get -3, -4, 10, and 6. Now we match them up. So g of -3. So -3 is here. I get 12. -4, I do not see -4. 10. I do not see a 10. And 6 is right here. I get a 4. So I have two ordered pairs. First order pair is 3, 12, and the other one is 12, 4. So my domain for this one would be 3, 12. And then the range would be 4, 12. Moving on to example 5. Given f of x equaling 2x minus 5 and g of x equaling 3x, find f of g of x and g of f of x, state the domain and range. So now here we don't have a table, we just have what the functions are. So what I need to do for finding f of g of x, I'm going to have f of g of x. So I have to put 3x in for the x of f of x. So this would be f of g of x would equal 2 times 3x, and then I'm going to subtract 5, which is going to give us 6x minus 5. And then the other one, if I did g of f of x, this one's going to give us, I have to put this now into this x. So this would be 3 times 2x minus 5. And that's going to give us 6x minus 15. Now, since both of these are linear equations, the domain and range for both would be all real. Okay. Moving on to our next one. We have f of x equaling negative x squared and g of x equaling 2x minus 3. We're going to do the same thing, find f of g of x and then g of f of x, then state the domain and range. We'll do red, do this one in red. So this would be, we need to put 2x minus 3 in for x squared. So I have negative, and then 2x minus 3, this is squared. So that's going to give us 4, a negative on the outside, we have 4x squared. 6x, negative 6x plus a negative 6x is a negative 12x, and then negative 3 squared is a positive 9. And then I distribute to negative, which will give us a negative 4x squared plus 12x minus 9. And then blue will do g of f of x. So now I have to put negative x squared in for x. This would be 2 times negative x squared minus 3, which this will give us a negative 2x squared minus 3. There are two composed functions. Now the domain and the range for the first one, that's a quadratic. So for that one, the domain for quadratics are all real. Now for the range, if I grab my calculator here, and let's graph this. So we have negative 4x squared plus 12x minus 9. I hit zoom number 6, so standard form. You see our graph right here. See, it never goes below or never goes above 0. So my range for this one would be y such that y has to be less than or equal to 0. Now the other one, the domain and then range, we also have a quadratic, so it's all real. And the range, y such that y is So now if we come to our calculator again, change this slightly. So this is a negative 2x squared. And then minus 3x. So let's just delete this. Minus 3, then hit graph. Find this part right here. This is the y-intercept, so it crosses at negative 3. So it goes below negative 3, so it has to be less than or equal to negative 3. Next, check this one. We have more composing. So here, f of g of x. So I need to put 2x cubed minus x in for x. So we'll do this one in blue. This is going to equal negative 2x cubed minus x plus 1, which will give us an answer of negative 2x cubed plus x plus 1. And we'll do green for this one, which would be puts negative x plus 1 in for x cubed, which will give us 2 times negative x plus 1 cubed minus negative x plus 1. And first, let's FOIL this, negative x plus 1. So this will give us x squared minus x plus 1. So x squared minus 2x plus 1. Yeah, multiply that by negative x plus 1. So this will give us a negative x cubed minus or plus x squared plus 2x squared minus 2x and then minus 1x plus 1. So this will give us a total of, we have x cubed plus 3x squared minus 3x plus 1. Then I have to multiply all that by 2. Which will give us, and then multiply that by 2, so that gives us 2x cubed plus 6x squared minus 6x plus 2. And then we have to subtract a negative x. So minus, really plus x minus 1, which will give us a final answer of 2x cubed plus 6x squared minus 5x and then plus 1. From that point here, now we can do the domain and range. So the domain for the blue, that's a cubic function, and cubic functions for the domain and range, those are all the same. So cubic functions, and it's negative, so this would be all real. And the range is all real. Just think of like it's got a odd degree and a negative leading coefficient. So that would be all real. And then for the other one, domain, also have a cubic function. These will also be all real numbers. And cubic functions, just remember they're going to look something like this when they are negative. When the leading coefficient is negative, this other one's a positive leading coefficient, so this would be looking this way, which would be all real numbers. And example 6, working with word problems. There's a movie theater charges $8.50 for each of the X tickets sold. The manager wants to determine how much the movie theater gets to keep ticket sales if they have to give the studio is 75% of the money earned on the ticket sales. If the amount they keep of each ticket sale is K of X, which composition represents the total amount of money the theater gets to keep? So the ticket sales is K of X equals, and they're selling each for $8.50. So $8.50 per ticket, X tickets, and then T of X is going to be the ticket sales, the money earned on it. So if the studio keeps, says how much the movie theater gets to keep of the ticket sales if they have to give the studio 75% of the money earned on ticket sales. So they keep 75%. They get to keep 25%. So that would be 0.25x. Now, which composition represents the total amount of money the theater gets to keep? So it gets to keep, they get to keep 25% of $8.50. So that one would be, I would have to put in T of X into K of X. So I'm going to have K of T of X. So the T of X is 0.25. So I would have to put $8.50 of 0.25 X, and this will give us a composed function of 2.125 X. And that would be our composed function. Next, the game store has a deal on old editions of video game consoles. They offer a 10% discount on the original cost, X. Sandra wants to combine the discount with a $25 rebate offered by the console manufacturer. Rebate means they just give you $25 back. If the cost of the console after the discount is D of X, and the cost after the rebate is taken is R of X, create a composition of functions to determine the cost of the console if the discount is applied before the rebate. So I have D of X equaling, so the discount is 10% discounts. That means you're paying 90% or 0.9 of the cost. And now the rebates, R of X, would be X, the price, then minus $25. So you get that $25 back. So we need to create a composition of functions to determine the cost of the console if the discount is applied before the rebate. So you put in the cost before you do the rebate. So I'm actually going to do R of D of X, which would be 0.9 X minus the 25. And this would be our composition. And our very last one, Jared creates video explaining how comic books are produced and distributed. He knows that he will get an average of 20,000 views per video. For each view, the website that hosts this video gives him 0.001 in advertisement revenue, along with a flat $5 fee each month. Suppose V of X represents the number of views, where X is the number of videos he makes in a month, and R of X represents his revenue per month, where X is the number of views. Create a composition of functions to determine the amount of revenue Jared earns given the number of videos he produces in a month. So V of X is this number of views. He gets 20,000 views per video, so that's 20,000 X. And then R of X represents his revenue per month, where X is the number of views. So that would be 0.001X. And then there's a flat fee of $5 per month. So V of x is going to equal 20,000 x, and then R of x is going to be 0.001 x plus your 5. So to find out determine the amount of revenue earns given the number of videos he produces in a month, we're going to put this in for this x. So this will be R of V of x. So R of V of x, we can get rid of the V of x. That would be these here. And the two choices that we have left would be A and B. The correct one would be letter B, because if I put 20,000 in for x, 20,000 x in for x, I would have 0.001 times 20,000 is 20x, and then I have plus 5. That is our lesson on operations on functions.